Welcome to This is Concrete, a podcast where we speak with the people whose work revolves around concrete and coatings. Let's get to what you came for.
Hello, this is Chad Gill, and I'm the host of the This is Concrete podcast, where I talk with leaders in facilities management, architecture, contracting, and more. This episode is brought to you by Concrete. Concrete is a concrete polishing and coatings company with nearly 20 years of experience working in the commercial, industrial, and residential markets. So whether you need smooth transitions for warehouse traffic, a show-stopping lobby floor, or a seamless concrete accent wall, we can provide the skill and imagination you need to make your concrete uncommon. So what are you waiting for? Visit us at thisisconcrete.com. We are also sponsored by the Workforce Recon, which is a project tracking software that connects the field to the office. Their app Field Recon is built with a field-first mentality, developed by contractors for contractors. It includes time and asset tracking, messaging, job documentation, and scheduling all in one place. So if you're tired of finding out what happened days later, check us out at workforcerecon.com and see your operations in real time. So joining me today is a man who needs a little introduction in the concrete industry. It's Bob Harris. He is the Senior Director of Decorative Concrete Consulting at SSI, a concrete expert who has worked as a Senior Superintendent at Disney, authored multiple books on concrete, and is a member of the Decorative Concrete Hall of Fame. So, Bob, thanks for coming on. I know I also want to mention that you work for a very tough boss in Atlanta, teaching classes, and I'm sure you would like to plug that one.
That's my 4'8" tall wife. She always makes the claim that be careful if you get sideways with her, she'll stand on a chair and be eye to eye with you. But you're referring to my wife, Leanne Harris, who's awesome, and unfortunately sometimes not recognized enough for what she's contributed to the industry. So, yeah, like you had mentioned, we started Decorative Concrete Institute back in 2000, and just a wide variety of classes that we teach. And we've got a new facility here in Temple, Georgia, and Leanne runs that because I'm full-time with Structural Services Incorporated. And then they allow me to occasionally do a class over a weekend. So I get to still dabble in what I love doing, which is decorative concrete.
I do. I agree. I think Leanne is one of the probably one of the least recognized, most hidden major players in the concrete industry that people just don't know. It's somebody I point to. I have two daughters. I have two sons also, but I have two daughters who are both 5 foot and 3/4 inches and 5 foot and 1 inch. Yes, there's a major difference in their height, they tell me. So I play the Leanne and say, hey, look, you can get it done in under 5 feet, So so this is great. I really appreciate you coming on. The topic for the day, which is probably pretty applicable to what most of us are getting into, is mixed design. This is that mystery science that we get these in our specifications. We're told, hey, here's the mixed design, and I don't know how many polished concrete contractors or decorative contractors get that mixed design. A contractor sends us, hey, take a look at this mixed design and tell me what you think. And you're like, well, I'm not strong in Latin either, so this is not going to go well. What's the mystery behind all this? What is mixed design?
Yeah, it's funny because with the literally tens and thousands of students that we've taught through the years, they asked a very similar question with regard to mixed design. And in our industry, Chad, as you know, it's not a one size fits all. So it's kind of like a Sam's winter brew versus a summer brew. And so a lot of times guys will have different mixed designs that complement, the application that they're doing. For example, if they're doing decorative stamp work, they'll may specify straight cement, keep the cement higher. So you get what we refer to as a fatty, kind of a creamier paste. So you're not trying to, mitigate all of the coarse aggregate, which is referred to as a harsh mix. Also, too, with polished concrete, we're seeing a lot of replacements. It started with what we call pozzolans, like a Class C or a Class F fly ash granulated slag, and that's where you're taking out a percentage of the cement and replacing it with, kind of a byproduct, if you will. And what I'm finding interesting as of late, and unfortunately, a lot of contractors are not even aware of this. The industry is changing, like it or not. You can fight it as much as you want, but it's not going to, have any effect. they're using what's referred to as a type 1L cement, and the L is referencing limestone. So they're taking interground limestone, taking out up to 15, in some cases 20% of the type 1-2 cement and replacing it with the limestone. So what does that mean? Well, what it means is, from a polishing perspective, I'm thinking, okay, is that going to reduce the reactivity of, like densifiers, for example, with polished concrete? Because densifiers rely on alkalinity. And so if we're taking out the type 1-2 cement, putting it, a replacement with this limestone, it's still the great unknown. And actually, we are doing a lot of extensive testing. Another thing that comes to mind is a reference called carbon cure. And again, the reason for these replacements is to reduce the carbon footprint. One of the worst pollutants in the world is the production of Portland cement. And so they think that, look, let's reduce that carbon footprint by using less cement, manufacturing less cement with all of these mysterious kind of unknown replacements. And we are having amazing results on what we're finding. So the compressive strengths, for example, on interground limestone, the type 1L cement, are at least equal to, and in some cases, even higher than type 1-2 cement. And it has to do with the fineness of these things. So the compressive strengths are there. But in terms of sustainability, and we talk about abrasion resistance, we're seeing it's the reverse of the higher compressive strength, because the specific gravity of the interground limestone is much finer, typically around 2.4, depending on where you are in the country. And typical type 1-2 cement is 3.14. And because of that fineness, it tends to float to the surface. It absorbs bleed water more. So finishers are getting on it prematurely and finishing it and trapping bleed water. And sometimes that results in delamination. So I understand, we got to protect our environment. I get that, but we also have to provide a sustainable surface for our clients.
So yeah, so a lot there. So to start at the beginning, so fly ash and slag, that's the top and bottom things that are coming out of like coal plants and things like that.
Correct.
And the idea there was cement replacement was for financial reasons mostly. They wanted to pay less for cement and put in these other items that can create a stickiness to the texture and things like that. And we ran into that with polishing, and particularly with staining, you would get some different effects with that. Then we moved into the ground limestone, like what you're talking about. And now it's the same thing of like maybe some of the supply chain is forcing them to go a little further that way. I mean, we're on, rotating, cement allotments almost, and trying to get concrete in. So it's a lot about this product, that the actual cement that's in the concrete trying to get in there. And then you talk about the compressive strength versus surface hardness. That surface hardness is really important to flooring contractors because that is our durable surface, right? I mean, is that all coming out correctly?
No, you're very accurate in that. And some, to give you an example of some of our big box clients, one in particular, big box client nationwide, and you guys all know who it is. But when they changed their mix design over to 15% fly ash, it just opened up a can of worms with a whole set of circumstances. Of course, in the winter months, you have early delayed setting with fly ash, and it takes a long time for those breaks or those compressive strengths to fully gain, the specified or the desired design requirements. And so guys are coming in and polishing in that particular account. They're adamant that they didn't want any sand exposure. They wanted a Class A cream finish, basically from the CPC, Concrete Polishing Council. And these guys would put 100 grit hybrid on there and then just take the surface right off, because it was still, after several months pouring in the winter, it was still wet. So to your point with these other replacements, the type 1L cements, we have another client that happens to use a lot of robotics. So these robotics, if you could imagine, they'll spin sometimes 360 with the wheels up to 3,000 revolutions each day. So you take that one robot and amateurize that over 100 robots in one facility, it's going to destroy these floors. It's just going to take that surface off. I'll tell you, we're real proud of our Decorative Concrete Institute. And I'm looking out the window as we speak, and we've got a whole field of decorative concrete out here that we've done, through the years, a couple years. And about 2 years ago, my local ready mix producer switched over to the type 1L cement. And I have panels that was poured that have never been designed or decorated yet, that have not been sealed. And everybody that comes here, they ask the question, they're like, man, that concrete looks so cool because it sparkles. And they asked me, what is that sparkle? Thinking that I've broadcast something into the surface. And I explained to them it's the sand. So, when we poured it, we don't abuse it. We pour a 5-inch slump, 5.5-inch slump, never throw water on the surface. But my point is, with no abrasion, some of that fine surface paste is already starting to wear away with no abrasion. Nobody's drove on it. And we just, there's just pedestrian traffic on it. So I'm always, monitoring this as we go along. So it's kind of interesting.
Are you seeing, you feel like, okay, normally when you see a substrate change like this, and that you're going to have to hit these kind of numbers and this kind of durability. I mean, we used to think that the checkout lane in a grocery store had a lot of traffic, but these robots you're talking about, that's tremendous traffic. So do you see, what are the chemical manufacturers doing as they're trying to get in? There's got to be some way. I'm sure if you can't fix it with the material, you got to hit it with the chemicals to do something to get that hardness back up.
No, you're right. And I smile because oftentimes we refer to that as a chemical cocktail. And, the admixture guys are doing what they're paid to do, which is to sell the ready mix producer admixtures. But I also am very old school in my approach with, your standard cement, sand, aggregate, and water. There's not going to be anything that's better than that in producing a predictable mix design. The problem is when we start loading these admixtures up, it does dramatically affect, the setting time. Sometimes, depending on the admixture that's used, it's delaying the set. It's making more plasticized concrete, like a 10% type A water reducer, for example. And what that means, though, to the finisher is you're not producing consistent setting concrete. And when you have inconsistent setting concrete, you end up with a differential finish. So, for example, if a lot of these 1,000-yard pours that our guys are out on, the design mix might be specified at a 5-inch slump plus or minus 1, meaning you can go up to a 6 or down to a 4. But then you have that one slump that's out of tolerance. Maybe it's a 7. And in the interest of the project, they decide to go ahead and pour that little bit of a wetter slump, and the finishers hit that wetter spot, and they have to keep finishing all the way around. And ultimately, for us decorative or us polished guys, that conveys in our finish result because you have a difference in finishing. So, sometimes it's not the best just to dose the concrete up with all of these admixtures. There are times where yes, you do need some admixtures, but even with admixtures, Chad, I'm finding that with these higher, replacements of type 1L, the ground limestone and now the carbon cure, you could put as much or as little of the admixture in as you'd like, and you're still going to have, that surface that's not as sustainable as, just straight cement.
So we're going to have to play the hand we're dealt as a contractor coming in there. And
unfortunately.
Yeah. And I don't know a lot about the placement. I don't know enough to be dangerous. But I know these set times make a difference because you may have budgeted for a straight cement mix placement. And so you were going to pour it that morning, finish it that afternoon, be home at night. But now you've got times when they're pouring and they're going to be finishing late into the night because of these set times. But what do you look at as a polisher when you're coming, like when that guy sends over his mix design and says, have a look, what are the things where you could go, I got to call somebody or I got to ask some questions. What are the trigger points where you say, I don't know. I mean, it's okay to not know. It's just not okay not to do anything when you don't know. So what do you look for?
Yeah, no, that's a good point. And there's a project that kind of immediately comes to mind. I was called down to a project down in Florida. The ready mix producer was on site. The owners and the owner's agent, us as the consultants, the place and finish guys, and the polisher for this job site meeting, to perform a condition survey. And there was a lot of extensive delamination in this case. And, I had asked the contractor, I said, did you guys use type 1L cement here? And he looked at me like, a deer in headlights. He said, what is that? I've never heard of that. And the ready mix producer looks over at me like, why is he asking that question? And I said, well, let's look at the batch ticket. And sure as heck, right there is, type 1L cement. Now, don't misunderstand what I'm saying. I'm not saying that just because you use type 1L cement, it's every floor is going to delaminate, but the blane is so much finer than like just a type 1-2 cement. It does lock in bleed water, so it gives the concrete finishing crew kind of a false sense of, wow, this is not bleeding out. Let's go ahead and get on it with our pans, and then they trap a layer of moisture under there, and it could absolutely contribute to delamination. So, more to your point, and as far as the question, if I'm a polisher, what am I looking for? At a bare minimum, I'm going to always, perform my most scratch test, my most pencil hardness, scratch hardness test to determine how hard or how soft that concrete. And I do that anyways, before all of these cement replacements. Back when I was a much younger man, back in the late 90s, when I started polishing concrete, I would still do that because I want to know, what diamond tool am I starting with? Am I starting with the metal? Am I starting with the hybrid? And so that's one good way. Also, too, when you're polishing, start on the higher side, knowing that potentially, the industry is going to be receiving a little bit softer surfaces because of all these replacements. And you can always, get more aggressive diamonds. But when you go too deep initially, you've reached the point of no return. You can't go backwards.
It is real hard to put cream back on concrete for sure.
It is very hard, but that's what I'm saying. It's so intriguing to me. I use our own facility here as kind of a testing. We walk on it to and from, our house. We live right here as well. And it's interesting to me, the concrete that we've designed and maybe did a stain class and we put sealer down, it looks perfect. The cream is still right there because we've locked it down with sealer. But just adjacent to that, with the same load of concrete where it hasn't been sealed, you've got that paste that's kind of came off the surface and is exposed to fine sands. It's really intriguing to me.
Yeah, and like I said, I mean, you probably feel like you walk there a lot, but you're no robot.
Exactly.
I mean, we're talking about tremendous duty cycles on these things.
Yeah.
So when you get into it, you're looking at this mixed design, it gets sent over to you. One of the things we're talking about, obviously, water to cement ratio. And so you're talking about how many pounds of water is there compared to pounds of cement in the mix? True cement, not the cement people talk about when they call and say they want a cement patio. It's the actual cement.
Yeah.
Pet peeve, man. It's all of us. But so that's one. And you want to be in the threes. I mean, low threes typically for that is ideal. Is that what you're looking for there?
For which now? For the
like your water to cement ratio on the standard mix you're looking for. Like if you see a 5, something's out of whack.
Yeah, exactly.
So
go ahead.
So you're looking for that in your water, and you come over, you see cement, and then you see something else as a cement replacement, and it's generally pretty obvious. But it may say fly ash, may some. What percentage in there? 5, 6, 7? Where you're like,
I got you.
Negligible.
Yeah, and unfortunately, most I kind of always ask the local guys here, the local contractors, how's your concrete acting? Is it sticky? And, is it bleeding? And most of the time, like I said, unfortunately, they're not even aware that there's been changes in our industry. So they order a traditional 3,500 mix, 3,500 PSI mix. It shows up on the job and they pour it. After the fact, they're like, wow, today is set slower for some reason. They need to look at the batch ticket so they understand what, in fact, is being, delivered to the job site. And I would say 9 times out of 10, like the story I just shared with you on that meeting I had in Florida, the guys looked at me like dazed. They'd never even heard of Type 1L cement. And come to find out, it's not an opinion of mine. We actually do what's referred to as a petrography test. And in that case, absolutely, there was premature finishing because there was trapped bleed water, which in that case contributed to lamination. So what I'm trying to say is be aware of what you're being delivered. Ask the question. Hey, I just did a pre-slab 2 days ago up in Lexington, Kentucky, and with a large ready mix producer that's very well known and reputable. And I asked them, I said, have you guys switched over to Type 1L cement? And they both chuckled. And they're like, no, not yet. We know it's coming, but we're still batching Type 1-2 cement.
Oh, yeah. And it does make it. But when when they give you a batch ticket and they give you a mixed design like that and you don't know, and then you unintentionally trap it in there, you're not in that necessary specific situation, but that opens you up to some real liability. You could have known.
Yeah, no, I agree with you. And that's the whole reason we're going through as a company. SSI is going through extensive testing right now currently to find out. We're doing in the field abrasion testing, and then I'm following up behind that with actual polishing testing, and chronicling every step of the way, making sure that every step is done the same time frame. So if we're starting with a 50 grit and it took us 3 minutes and 42 seconds to do a 10 by 10 area, we make sure that we do it the same. Every step is exactly the same. And we're testing, in this instance, non-carbon cured concrete, traditional Type 1-2 cement versus carbon cured concrete. And the results have actually been pretty amazing. Amazing. Yeah.
So amazing in the difference, or amazing because you can accomplish things you didn't think you were going to be able to accomplish?
Because of the differences. So, for example, what I've tested personally so far, the carbon cured concrete was scratching at a 4.5 on the Mohs hardness, and on non-carbon cured, it was scratching at a 6.5. And we did roughness average testing, RA testing, and there was a huge difference in the RA as well. We found that we were getting a little bit more pitting with carbon cured concrete versus non-carbon cured. And gloss DOI and haze was not too dramatically different. But I did notice, the first 3 or 4 steps on each test we were doing it wet, and the amount of slurry that the carbon cure was producing versus non-carbon cure was almost double, and in some instances triple the amount of slurry, which makes sense because it's a softer surface.
Yeah, that's great. So pitting, how do you correlate? So pitting, aside from these items, when you see pitting in concrete and people ask me, hey man, do I need to account for grouting? Am I going to have pitting? How do you know? And is that a mixed design? Is that environmental? Is that application based? Where does that come from?
So yes, and yes again. So
oh no.
think about it this way. So if you take limestone rock and you start crushing it and crushing it and crushing it down to the point where it's finer than a typical type 1-2 cement, that's referred to as a specific gravity. Those fines are going to float to the surface, carrying some cement or some sand particle to it as well. And so that could be one culprit. Another culprit, and this is a big one, is the amount of sand that's in the mix and the type of sand. And again, most polishers don't even, what do you mean? I have a choice between manufactured sand and natural sand. And so when you see a mixed design that contains a higher percentage of manufactured sand, which once again is the grinding of an aggregate that becomes so fine you can use it as a sand in the mixed design. But unfortunately, manufactured sand is very angular. And so you can imagine these little nibs hanging out there. And when our diamonds pass over the top of that, it's going to pull the sand. Where conversely, natural sand is rounded and it's washed and it's clean. So, it's not as aggressive and you get much less pull out. So that's another contributing factor. And then to your point, the way that was placed and finished and ultimately cured too is going to contribute to pitting.
So most times pitting is really, there was something there and then it got pulled free of the surface either during placement or during polishing or both.
That's right. That's exactly right.
Okay, perfect. Yeah. And that's something to kind of consider, trying to know where it is. And then we just try to make sure that when we bid it, we just tell people, hey, look, it doesn't include grouting, but you should account for grouting because you may need it.
Yeah. And so I'm sorry. So we've got some national accounts that we oversee the mixed design, we oversee the placement of the finishing, and then I come behind and batting cleanup, oversee the polishing and producing the mock-ups to make sure that they're hitting the specified measurables. And so as a general rule, let's say that we're doing an area that's 20 by 20. What I'll do is I'll break that down into percentages. And in that 400 square feet of surface area, if we have 20% of the area, or maybe it's 25% or more that it's exhibiting pitting, we'll make the decision to go ahead and grout coat. And so we will call our client, hey, look, we got pitting here. In reviewing the mixed design, they did put 10% manufactured sand, and it's we're getting some pits. I recommend that you go ahead and grout coat. But as to your point, that's going to add 75 cents a square foot, depending on where you are in the United States, to put the grout coat down and polish it off. Hands down, you're going to get a much better surface, as by applying a grout coat. But when you have, if you're building 200 grocery stores and the average footprint is 35,000 or 40,000 square feet, and you amateurize that, over 75 cents a square foot, that's a lot of money that somebody's paying for.
For sure. And there's multiple ways of grouting. Like, what do you see as like good ways of grouting?
Yeah, it's funny. I think back, I feel kind of like a Neanderthal back when we, dragging our knuckles when we first started polishing, because there was no hotline to call anybody and get questions. It was design, build, and learn as you go. Back then, we were taking some of the cement, fines, because we were grinding primarily dry there. mixing it into resins or epoxies. And also we were using micro toppings, like you would have a finished floor with a micro topping. We were sifting some of that out and putting micro toppings down. But the problem with those processes are somewhat outdated now. It takes a lot of time for those to dry. And in our world today, we don't have a lot of time. So we use resinous materials. And there's some, large manufacturers that make surface refinement grouts, basically, that go down, real thin. Viscosity is very, very thin. So it kind of penetrates down into the pores of that. And you typically can grind it off in 3 hours, 3 or 4 hours. So
does that help you? Obviously you want to feel pitting, but does that help you with hardness? Does that play into some of these scenarios to just make a floor more stable?
It can help. So, it's funny. I see our hotline, our phone, when we have the coolest part of the year in the winter, the phone calls come in. And of course, when we have the hottest part of the summer, the phone calls, there's those two issues. And so when they're pouring interior floor slabs, for example, in a tilt-up construction environment, obviously for interior power trowel concrete, you do not put air entraining admixture in there. You never power trowel, concrete that has air entraining admixture. And when they're doing the tilt-up slabs in the winter, rain gets in there. And of course, we know what happens. The concrete doesn't have air purposely. Moisture permeates down into the pores and the porosity of the concrete. And when it freezes, it expands and it pops out. And so now we've got all of these, little pits and blowouts and stuff. So in that case, absolutely, it's going to tighten up a surface, and it's going to give you some sustainability and longevity for, abrasion or forklift lift traffic. In terms of changing the actual hardness of the paste, not really, but it does kind of help lock and hold everything together.
And we've even used the grout coat in rare occasions as part of our protection plan. We would grout, we'd grind, get our main grind done, grout, and then leave and then come back. And we use that as a part of our protection plan.
I think it's a great idea. And I work with several contractors that have done the same. What's going to happen during the construction of that. Exactly. So that it is like a great form of protection for sure.
It's interesting. So a lot of this savings, the green, the environmental, and I don't scoff at it. I mean, I used to be a firm believer. It was like, if you opened a can of sealer and everything around you died, you probably got a great sealer, but it's not politically correct. It's not good, but so there's a lot of green and I like you, I said, yeah, we needed to do, but it's kind of like coloring, we started staining because it's expensive to put color throughout a slab and you only see the surface. Is there potential here where you see more micro topping and they create a really hard surface and then they have these, carbon and ground lime inside of, as your substrate kind of thing? I mean, we're getting back to where we're putting a floor on top of a floor again.
You're just talking in general terms, not specific to polishing, I presume.
Yeah, just in general terms. I mean, yeah.
I don't know that it's reached that yet, because a lot of what we're doing is still, in its infancy stages, with the exception of slag and fly ash. That's been around for years and years, as you had alluded to earlier. But the underground limestone and the carbon cure, it's still relatively new. So I don't think we've felt the effects of that relative to putting micro toppings back over the floor. Now, could that be a form of remediation? 100%. I look at some of our stuff out here. If I was going to polish, it's punky now and it's pitted just because of this underground limestone. So it would be a prime candidate for receiving a micro topping and or a stamp overlay in that case.
So you do think you can still bond to it? It's just it's got structural. Yeah.
Yeah, it's almost kind of over time, with rainwater and going over the surface over time. That's right.
Yeah, no, I think that makes sense. I mean, it's a lot to consider when you're doing these things, and I think that's and I think as whoever you are, whether you're decorative or polishing, if and when you're placing too, it's like I think you just need to know those trigger points to say, hey, we've got something here I don't understand, and do take a look at that mix design, because it'll, like I said, we did a particular job and it was spec'd to be a 3,500 PSI slab. And when we showed up, the batch tickets were showing that they were hitting 7,000 and 8,000 PSI breaks.
Yeah.
This guy was like, man, look at how good the concrete is. I'm like, do you know what it's going to take for me to get to an aggregate exposure on this?
Right.
And that's one thing I'm curious to ask you. What do you do when, like, I don't know if everybody seems to understand that those are minimum ratings. 3,500 is the minimum. It's like minimum octane in gas. You can't get in an 8,000 slab. And, how do you protect yourself for that as a polisher?
Yeah. Well, that's it. You do your upfront work, and then you would, it's difficult because oftentimes these jobs, they've not done compressive breaks, unless it's a commercial job where they've done it and they have an independent testing lab out taking unit weight, air, slump, air and slumps. So oftentimes guys don't have a clue. So if we go out on a job site and, we throw a 25 grit soft bond metal wet, and it's not touching the surface, and we scratch it and it's scratching at 8.5 on the most hardness, you throw your hands up. And if you, go to the owner at that point and say, hey, our diamond tools are not cutting this, what's the compressive strength? They're not going to know unless you're doing a national account that has independent testing agencies out there testing the concrete. So you may put, a stipulation or a clause in your contract. Most traditional concrete, that's the 3,500 PSI concrete that's been adequately cured, typically would scratch between a 5.5 and say a 7.5. Anything above that, we may have to have a back charge scenario or something like that. That's why it's important to do your upfront work in terms of every surface we polish, we scratch it. Is it like time tested, and is that the end of all, words? No, it's not, but it's at least a starting foundation for you to understand how hard or how soft that surface is.
Well, I think it's part of the story. I think it's kind of like expectation. People ask me, goes, man, I don't understand. The best floor we've ever done was this, 150-year-old warehouse or something. I'm like, that's because you didn't expect it to turn out good.
Right.
That's why you think it's the best floor you've ever done. And I think, a lot of times, and, what we say is, if I can tell you up front, it's explanation. Once we have a problem, it's nothing but excuses.
Yeah.
So that's a good way, like that hardness thing, look for that hardness, look at these mixed designs, try to identify your problem areas, early. Protect yourself from them.
For sure.
Well, no, man, that's fantastic. So are you doing much stuff? So I'm asking, this is more out of curiosity. Do you see a lot, have you done much in like the China market or European market, stuff like that? Do you see a lot of different concrete other than the United States of what they're doing? Conversely, I know they're pouring a tremendous amount of concrete in China.
Yeah. So it's been, I made 3 trips over to China. It's been now 4 years ago, but we really weren't there to oversee the placing and finishing of concrete. Their government, they wanted me over as a keynote speaker at one of their pavement seminars that they were having. And then a polishing manufacturer invited both Leanne and I over to teach polished concrete over there. But it's an interesting lifestyle, to say the least. And yeah, they're just cranking out the concrete, to the point. And that's a big producer of Portland cement, as you know. And not to make light of a bad scenario, but the air quality as a result of that over there is so bad that, your eyes are watering. And I'm not exaggerating. We couldn't see across the street. The smog was so bad on some days, depending on where you are in China. So it's a completely different game when you travel abroad. I do remember pouring concrete in Germany, thinking this is the best concrete. This was years and years ago I've ever touched, and the state of the art of equipment shows up to pour. And I've poured my share of concrete in Italy, and they get it there as well. They've got their mixed designs dialed in, and they do it well.
Yeah, no, it is. There's plenty of good reasons to be in Italy, and good mixed design, you could probably add on to that.
Well, yeah.
Bob, I really appreciate the time. Gosh, there's 1,000 things we could ask you, but thanks for the rundown on the mixed design.
No problem.
Terrific. We'll definitely get a link to Leanne's company there, the Decorative Concrete Institute, and certainly can vouch for the training down there. I'm sure they can hook you up with a good motorcycle ride plan around there as well.
I love it.
Absolutely. Thank you, Bob. We'll talk to you very soon.
Chad, it was good catching up with you. Thank you very much.
Thanks for listening to This is Concrete. We look forward to you joining us next time. Be sure to click subscribe to get future episodes.